Hey, Sean here with Wherobots. We just released a new notebook that shows how to work with the Foursquare Places data in our platform. In this video, I'm going to give you a very quick preview of what's included. And if you like what you see here, you can sign up for free on wherobots.com and give this notebook a spin. By the end of this, we will have created a choropleth map like the one I'm showing here. Now, this one in particular shows the number of coffee shops in San Francisco sorted by neighborhood. So with it, we can see which neighborhood has the least coffee shops, which has the most. You get the idea. Now, there's a lot of information in this notebook. It's meant to be a relatively thorough guide on how to work with this data inside of Wherobots. I'm not going to cover it all in this short video, but it is all there if you need it. To start, we're going to create the Sedona context. That's this line of code here. What this does is it spins up the compute cluster that will allow us to distribute the workload among a number of different compute nodes. One of the things that I appreciate about Wherobots is that this distributed processing happens all behind the scenes using a serverless architecture. Now, we're getting up to 20 times faster processing speeds than other solutions, but without having to manually configure and manage clusters. This makes a huge difference when you're working with geospatial data at scale. This next section shows how we can pull in the data. The Foursquare Places data is already in the Wherobots Open Data Catalog, so we don't need to do anything too fancy to access it. We also have versioning for the Foursquare data. So using SQL, right down here, we can select which release of the data we want to work with. Now that's great if you want to tie your analysis to a particular version of the Foursquare data. Next, what we're going to do is select the places table right here and read that in as a table that we can access with Spatial SQL. And we're actually going to go ahead here and select the columns that we want to use. Now, what's great about the Wherobots approach is that you can just use familiar SQL context to work with even the most complex geospatial data sets. There's no need to learn a completely new tool or language. Okay, so now that we have the data, and you can see it here in this table, let's say we want to select a specific region like the United States. Well, the United States is a defined area in the dataset, so we can actually just do this using vanilla SQL. But what if we wanted to work with an area that is not already defined in the dataset? That's where Spatial SQL comes in. We can define, right down here, any arbitrary polygon or multi-polygon and do a spatial join with that polygon to get the data only for that region. Wherobots comes with over 190 vector functions out of the box, so you have all the capabilities you need without installing and configuring additional tools. What we have here is actually the multi-polygon of the county of San Francisco, and I am selecting the places data that is contained by that polygon. We can see the results here as a table, or as I prefer it, we can map it using Sedona Kepler and take a look at here on the map. And yes, that is a lot of points. Now, say we want to select a specific location type. For this example, I'm going to select Starbucks locations. I can do this with some relatively straightforward SQL here, and we can map it once again using Sedona Kepler. Another option when working with Foursquare Places data is filtering by categories. Foursquare has a number of different categories in the dataset. You can see here, as I scroll down a bit, the top 20 or so categories that have the most entries in this San Francisco area polygon. What we're going to do is we're going to select the one at the bottom here that gets us coffee shops. Now, here's how we put together some SQL to subset by that category. And once again, we can map this using Sedona Kepler. So as I scroll in, we can take a look at all of the coffee shops around the San Francisco county. Another common process you may want to try is to aggregate those points by some geometry type. So let's say we want to aggregate by census block groups, by H3 hexagons, by something else. This is where the serverless architecture of Wherobots really shines. Even as we're filtering and doing spatial joins with large data sets, we don't have to worry about resource allocation or scaling. The platform handles all of that automatically, and so we can focus on the analysis instead of the infrastructure. We could aggregate, as I said, by H3 hexagon cells, census block groups, any other geometry we care about. However, for this analysis, I thought it would be fun to aggregate by San Francisco neighborhoods. So what I'm doing down here is I'm reading in a CSV file that has the polygons for the different neighborhoods in San Francisco. After I read it in, you can actually see the list of them right down here, or at least the first few. So we've got Seacliff, Haight-Ashbury, Outer Mission, Inner Sunset, etc. If you're familiar with San Francisco at all, you probably know these names. Now we will do a spatial join of these coffee shops to these neighborhood polygons. That will get us the count for each one. This kind of spatial join operation is typically very expensive computationally, but Wherobots' optimized spatial compute engine makes it surprisingly fast and efficient, even with large datasets. Our benchmarking has shown Wherobots to run spatial operations as much as 20 times faster than other solutions. So you can see the beginning of the result here in this data frame. And what I would like to do next is map it as a choropleth map. So we can scroll down here and see the results. Here's the setup for the choropleth map. There's also a config file here that's just customizing the colors. And if I hover over these, it should give me the number of coffee shops in that neighborhood. So, for example, this is the Inner Richmond here. It looks like we have about 37 coffee shops, and you can even see the first several of them listed there. Over here in downtown, where the Wherobots office is, it looks like we have about 186 coffee shops. So I have a good bit of choice there. Now, one question that might come to mind when working with the Foursquare Places data is, how is this POI data different from other POI datasets out there, such as Overture maps? I think one of the big differences is the FourSqaure Placemaker Tools. The Placemaker Tools are a set of web-based tools where community members and individuals can go in and add new venues, update existing information, and validate place data. And one final thing I'd like to note before we wrap up is that Wherobots is 100% compatible with Apache Sedona. That means you are never locked into our platform. If you're interested in learning more, feel free to reach out to me, or you can create a free account and try running this notebook on wherobots.com.